In this video, I'm going to be talking about amount of substance. And the main idea around this amount of substance, which I'm going to be talking about, is the mole. The mole. And this isn't the mole that, with the whole nose and the eyes and the mouth. No, we're not talking about that kind of mole. We're talking about the mole, which is a way of which is the standard unit, the standard international unit for quantifying amount of substance. And the term amount of substance can be very confusing because it seems a little bit ambiguous. What does amount of substance mean? Are we talking about the weight of the substance, the mass of the substance? Are we talking about the size of the substance? What does amount of substance mean? Well, when we're talking about the mole and amount of substance in chemistry, what we mean by amount of substance is literally number of particles. What we're literally talking about is the number of particles. And when we say number of particles, what we're referring to is any kind of particle. We could be talking about number of molecules. We could be talking about number of ions. We could be talking about number of atoms. We could be talking about any number of things. We could even be talking about number of electrons. So when we're talking about amount of substance, it could be any substance. It's just the number of particles of that substance, which we're talking about when we're talking about the mole. And the mole is a unit and is specific to a certain amount of a particular substance, a particular number of particles, therefore, of that substance. And the number which we use as a standard unit of an amount of substance is a very, very big number. The number to 4 decimal places, 4 significant figures, is 6.022 times 10 to the power of 23. Huge number. 23 to the power of 23. That is massive. It's massive. But because we're looking at things on an atomic scale, 6.022 times 10 to the power of 23 atoms is not actually that big when we're looking at it from an atomic perspective, and looking at it from our perspective onto an atomic level. 6.022 times 10 to the power of 23 atoms is not that big. Now, this number here, this number is always the number which is referred to when we say we have 1 mole of a particular, mole, we usually shorten mole to MOL. That's the unit we represent as mole, and sometimes represented by the symbol N as well. N. And 1 mole of a substance would be equal to 6.022 times 10 to the power of 23 particles of that substance. So as you can see, when we say amount of substance, we mean number of particles of that substance. And when we refer to 1 mole, it's always this number, 6.022 times 10 to the power of 23. And chemists have created a name for this number, and the name we give to this number is Avogadro's constant. And Avogadro's constant, let me just write this out. Avogadro, constant. I'm not going to go into too much detail about Avogadro. I don't know that much about him, but I know that he made a significant impact in chemistry because he made theories about gas volumes. He made a theory which involved the idea that in a specific volume at the same pressure it contains the same number of particles for any given type of gas molecule. It contains the same amount in that volume at the same pressure. And this theory we made had a big impact, and later on in history this constant was named after him. And I'll write it down again: 6.022 times 10 to the power of 23. Usually, let's say you're in an exam or something like that, you would get this number on your formula sheet. Most likely, yeah, you'd get this number on your formula sheet. You don't have to like memorize anything. It would be helpful, but you don't actually need to. And that's the basics of the mole. Now, let's say we had a given number of particles, and we had a question, so to speak. We had a question which was asking us to find out the number of moles of a certain substance present. Let's say, and this can be represented in the form of an equation, a general equation. So what we can say is number of moles and this is going to be of a particular substance. A particular substance is equal to, I'll do this in white, is equal to the number of particles you have, number of particles. So if it gives you the number of particles of that substance, that's your the number of particles you have. And we divide this number of particles which you have by the number of particles in a mole. And I just told you the number of particles in a mole, 6.022 times 10 to the power of 23. Now, let me finish this. Number of particles in a mole. That would be 6.022 times 10 to the power of minus 23 particles. That's a weird arrow. It's meant to point upwards. Anyway, so this would be a general equation. The number of moles of that substance would be the number of particles you have divided by the number of particles which are present in a mole, and this number doesn't change. It's the same. No, this is a constant, and Avogadro's constant is represented by the symbol Na. Okay. Now, let's do a little example question. Let's say I have 1.5 times 10 to the power of 24 carbon atoms. And let's say we're asked to find out how many moles is this amount of carbon atoms contain. So what we do is we get this number and we divide it by the number of moles in one mole of the substance, the number of particles in a mole. So what we do is we get this and put this at the top, number of particles you have, 1.5 times 10 to the power of 24, and we divide this by the number of particles in the mole, which is 6.022 times 10 to the power of minus 23. We can represent it as a 6.002, but I'm going to do it here for 3 decimal places for this question. Okay, so 1.5 times 10 to the power of 24 divided by 6.022 times 10 to the power of minus 23. And that gives us equals 2.49. Alright, do this to 3 significant figures. 2.49 times 10 to the power of 46. Oops. Oh my gosh, I did not make the fatal mistake. don't do this, please, guys. I put minus in there by accident. This cannot be correct. Let me just adjust my calculation. Yeah, it's meant to be just to the power of 23. 2. That yeah. Yeah, that's this would equal 2.49 moles. Sorry about that mistake. This would be the number of moles present in that amount of the substance, and that's basically how moles work. And also, there's something also known as molar ratios. Molar ratios is like the ratio between the amounts of substance of different molecules in a given equation. So let's say I had an equation where I was forming carbon dioxide from carbon and a molecule of oxygen. So C plus O2 forms CO2. What we have here is 1 mole of carbon. So 1 mole of carbon here. And here we have 1 mole of oxygen molecules. And it's quite important to specify that it's oxygen molecules because it's in the form of an oxygen molecule and not just O. If we said 1 mole of oxygen, it would be a bit ambiguous, and it's very important to be specific, because if it was confused with 1 mole of oxygen, we'd end up calculating something with double the amount of particles than we're trying to. I mean, if we calculate it with this, we'd have half the amount of particles than the amount of, well, half the amount of oxygen atoms than we would have with O2. So it's very important to make sure you specify that it's a mole of oxygen molecules rather than oxygen atoms. In this case, that would not be correct. So that's a molar ratio. And that's basically all there is about moles in basic terms. And I'll make some more videos about moles in relation to molar mass, concentration, volume, all of those things. I hope this video was quite helpful. Bye.